Hello everyone, I'm here to discuss about reflection of light. I'm Regibel Mora Olarte, grade 12 ABM Sole Proprietorship. So, I'm here to discuss about reflection of light. From the word reflection of light, what comes to your my mind? For me, reflection of light comes to my mind is reflection of light is light that reflect to the things that the light that reflect to the things that we reflect to the eyes, like examples, sun reflect to the things like an sun na reflect iya light mga sim or yero. So an iya light naban siya hasim, so that pag nakita natin natatawag natin hiya nga reflection of light. So ito here ako understanding of reflection of light. So how image form in the mirror? So there are times na napapakiana natin niya kaya ano daw kung ada kita mirror na image, because when a mirror reflect light, it forms an image. An image is a copy of an object that is formed by reflection or refraction. Asya ito hiya, it image na form in the mirror. So there are two types of curved mirror. Number 1, concave mirror, and number 2 is convex mirror. Concave mirror are mirror that has a surface that is curved inward. This is also called conveying mirror. Convex mirror has a surface curving outward. It spreads cut out the light as it reflects to this mirror. That is why it is called so-called diverging mirror. And there are 5 parts of curved mirror. Number 1, vertex mirror, and number 2, focal point mirror, and number 3, center of curvature. Geometrical center of the mirror, its symbols C. And number 4, focal length mirror, distance between the focal point and the vertex. And for the last is principal axis mirror, the horizontal line that passes through the curved mirror and the center of the curvature. So vertex, kwan ito hiya. A vertex is a point where two straight line or rays meet. Asya ito hiya, it vertex. So ang sunod liwat, focal point mirror. So focal point mirror mean kung ito hiya, center it iya point kuan center of attraction. Siya ito hiya, it focal point. So number 3, center of curvature. Geometrical center of the mirror, its symbols is C. And number 4 is focal point. And the vertex, its symbols of F.
My name is Joyce M. Rosales. Lesson 2. I will discuss about the refraction of light. What is reflection of light? Refraction of light is the bending of a wave of light when it enters a medium where its speed is different. The reflection of light when it passes from a fast medium to slow medium bend the light ray toward the normal to the boundary between the two media. Refraction of light is defined as a change in the speed of light that causes a change in the direction of the light wave as it travels across the boundary of a uniform medium. On a uniform medium, the light bends depending on the density of the medium. When the medium is less dense, the light has a greater speed. On the other hand, when the medium is more dense, the travel of light is is lesser. This also follows the principle of less time. As a result, light bends towards the normal line if it is enter a medium where speed of light is lesser. On the other hand, it will bend away from the normal line if light enter a material where speed of light is larger than it is speed in the first medium. As a result, the location of the medium image differ. What if the medium is non-uniform? Will it be the same as uniform medium? One example of non-uniform medium is air. A variation of the density of air produces refraction because light travels slower in a denser medium. When the light reflects or bends on a non-uniform medium, it creates an illusion of water that produces an inverted image that is observed hundreds of kilometers. This is known as a mirage. However, this only happens on sunny day, especially when the sun is at its peak. When the sun hits the roadway to high temperature, it's turned to the surrounding air hot, keeping the air just above the roadway at a higher temperature than the average day's temperature. Hot air tends to be less optically dense the colder air. As such, a uniform medium is created. While light travel on a uniform medium air with average day temperature, it will reflect when the traveling through on a non-uniform medium air above the roadway.
White light is a mixture of red, orange, yellow, green, blue, indigo, and violet light. It is our eyes that sees the mixture as white. As shown in the previous activity, the color of the object that you see is largely due to the way those objects interact with light and ultimately reflect or transmit to our eyes. The color of an object interact with light and ultimately rather the color is in the light that shines upon it and is ultimately reflected or transmitted to our eyes, while objects that are neither white or black have their specific color due to the pigment and transmit or reflect the rest. Electrons of atoms vibrate at specific frequencies or at their natural frequencies. When a light wave with the same frequency as the electron's natural frequency hits the atoms, the electrons will start to vibrate in resonance with the frequency of the light source. When the electrons vibrate in resonance with the light energy, they vibrate for a long time with high amplitude. They will enable them to absorb the light energy and turn into the thermal energy. When light is absorbed by materials, it can no longer be seen by a human eye. So, ang electron ng isang atoms ay nagbabibrate kapag nasa particular na frequency. Kapag ang light wave ay nahits ang atom, ang electrons ay magsisimula ng mag-vibrate. At kapag nag-vibrate naman ang electrons, nagba-vibrate siya for a long time with high amplitude. Ibig sabihin ng amplitude ay high or taas. Kapag ganun ay na-absorb nito ang light energy. Kapag na-absorb naman ang light, hindi na natin ito makikita gamit ang ating mata. This phenomenon is clearly observed by using a red laser light to pass the cellophane, but when using a green cellophane, the red laser will not be able to pass unhindered. Cellophane and colored glasses are transparent because you can see through them. However, the color of what you see is changed when using a red cellophane. The red cellophane will be absorb all the other colors but would easily let the red laser pass through. But using a green cellophane, it would also absorb all the other colors. Specifically, if using a red laser, the red laser will also be absorbed those making the red laser 100 before passing through the green cellophane. Refraction is the bending of light as the passes through one medium into another, or water, glass, and air. As you look at the straw in the glass of water, the light coming from the straw to your eyes bend as it passes through three different medium, namely is water, air, and glass. As seen in this figure, light's actual travel through a given medium. It travels in a straight line. However, when the light passes from one medium, it continues to travel in the straight line only now. Pero kapag nagamit kita ng mga green cellophane, ito ay sumisipsip din ng lahat ng iba pang kulay. Lalo na kung gumagamit ng isang pulang laser. Ang pulang laser ay mag-absorb din, kaya ang pulang laser ay nahadlangan bago dumaan sa green cellophane. Ang refraction ay ang pagyuko or pagbaba ng liwanag habang dumadaan ito sa isang daluyan patungo sa iba pa, or sabihin, tubig, hangin, or salamin. Habang tinitignan mo ang straw sa baso ng tubig, ang liwanag na nagmumula sa straw patungo sa iyong mga mata ay mababa. Habang ito ay dumadaan sa tatlong magkakaibang daluyan, yun ay ang tubig, salamin, at hangin. Gayunpaman, pag ang mga ilaw ay pumasok mula sa isang daluyan, it's continue to travel in a straight line. The direction of the line is different than it was in the former medium, in which sighting of an object light from the object changes in media or the wave to your eyes. A visual distortion result as the sense in phenomena mentioned. So ang diliwat, ang direksyon ng linyang iyon kaysa sa ibang media. Kung kapag nakikita ang isang bagay, ang liwanag mula sa bagay na iyon ay nagbabago ng media sa daan patungo sa iyong mata.
The world around us is made up of a varying shades of different colors. As a result, the perception of color of surrounding object is subjective and differs for each of us. That being said, regardless of our subjective perception, the color of the light itself has an objective cause. Have you ever wondered how a rainbow comes to be? The phenomenon of splitting a visible light into its component colors is called dispersion. Dispersion of light is caused by the change of speed of light ray, resulting in angle of deviation of each wavelength by a different amount. So, what exactly is light dispersion? When white light is transmitted through a prism, it is split into 7 component colors. The sun emits light waves with a range of frequencies. Some of these frequencies fall within the visible light spectrum and thus are detectable by the human eye. Red, orange, yellow, green, blue, violet. For you to understand, please watch this video.
cloud bases are often gray as a result of the same scattering that makes them white. When light is scattered in a cloud, it is usually sent back upwards or out of the sides of the cloud, making the top and sides of the cloud wider than the base, which receives less light. This is more prominent in rain clouds because the cloud droplets are bigger and therefore denser, making it harder for the light to reach the bottom of the cloud, giving it a darker, intimidating appearance.
Good day, everyone. I'm Jarrell Modesto Catapal, and I'm here to discuss about the Hertz production of radio pulses. So, one of the 7 waves in electromagnetic spectrum is radio wave. So when we say radio wave, it has the longest wavelength and has the lowest frequency. It is widely used for communication and transmission of information regardless the distance of the sender and receiver. So, dako nit iabuli ka communication pag-transmit hiton information regardless pa iton kaharayo between sender and receiver. He used a spark gap attached to an induction coil and a separate spark gap on a receiving antenna. When waves created by the sparks on the coil transmitter were picked up by receiving antenna, sparks would jump into gaps as well. So when we say spark gap, it consists of arrangement of 2 conducting electrodes. So in the middle of the 2 conducting electrodes, it has a spark. Gumamit si Hertz hin spark gap na nakakabit nga doon induction coil. While ano sa liwat na nakahiwalay nga spark gap is tikaduluwat hiya receiving antenna. To prove there really was radiation emitted, it had to be detected. Hertz used a piece of copper wire 1 mm thick, bent into a circle of diameter of 7.5 cm, with a small brass spear on one end, and the other end of the wire was pointed, with the point near the spear. Para mapatunayan na may talaga radiation na iging gagawas, gumamit si Hertz hin usa ka bugos nga copper nga may dahiya 1 mm nga kadakmol. While han usa liwat nga bilog may daliwat hiya 7.5 cm. So he added a screw mechanism so that the point could be moved very close to the spear in a controlled fashion. This receiver was designed so that current oscillating back and forth in the wire would have a natural period close to that of the transmitter described above. The presence of oscillating charge in the receiver would be signaled by sparks across the tiny gap between the point of the spear. Typically, this gap was hundreds and millimeter. So nag-adihan mekanismo ang tornilyo para liwat ang puntos is mabalin nga doon mas harani nga globo or mas kontrolado pa nga paraan. In more advanced experiments, Hertz measured the velocity of electromagnetic radiation and found it to be the same as light's velocity. He also showed that the nature of radio waves, reflection and refraction was the same as those of light, and established beyond any doubt that the light is electromagnetic radiation obeying the Maxwell equations. In Hertz's experiment, when the alternating current goes to other way, a spark goes to other way, and another half wave is generated, Hertz was not only be able to detect the waves, he was able to measure their wavelength and velocity. Then he calculated the speed of the waves was equal to the speed of light, as Maxwell had predicted. The frequency of the wave, which is the number of cycles created in a unit of time, was named Hertz in honor of his name. Para liwat ha mas advanced pang experiment, gin-calculate ni Hertz ang kadagmithan electromagnetic radiation nga nakita niya nga pareho liwat ang kadagmithan light. Ginpakita gap niya ang likas sa katangihan, han reflection and refraction and radio wave nga kapareho liwat ang velocity han light. So, waray katukoy ni Hertz ang mga wave. Nasukat gihap ini niya ang kahalaba or ang kadagmit hadto. Pagkatapos is igin-calculate liwat niya ang kadagmit han mga wave nga kasing dagmit liwat hiya han light. Ang dalas liwatan usa nga wave nga kunhain niya nabibilong nga cycle is katumbas liwat hiya usa ka unit nga oras. Nga ginpangaranan niya nga hertz bilang parangal nagapiyahan ngaran ni Hertz. Summing up Hertz's importance, his experiments and discovery of radio pulse, an intense burst of radio frequency energy lasting for a fraction of a second would soon trigger the invention of the wireless telegraph, radio, television, and other forms of telecommunication, and diagnostic technology that would help easy people's life and work. So, ang pagbubuod liwat han kahalagan ni Hertz is an iya mga experiment, or ang pagtuklas han mga radio pulse. Habang nagtitikaharan niya ang pagkuan ng radio pulse, mas nagtitika trigger liwat hiyahan pag-imbento han mga wireless telegraph, radio, television, ngan iba pa nga mga telecommunication and diagnostic. So teknolohiya dako hiyat bulig haaton para mapadagmit itaton mga trabaho. That's all and thank you.
For you to understand, please watch this video.